Good morning, S1. Today we're going to look at different concentrations and how to make saturated solutions. So by the end of this video, we'll have learned how solutions of different concentrations can be made, and we'll have looked at saturation. The content, so the knowledge for this lesson is as follows, and then I will explain it. A concentrated solution is one in which lots and lots of solute is dissolved in the solvent. So remember, if we used water as our liquid, our solvent, and we added something like sugar, the solute, you would add a spoonful of sugar and it would dissolve. You would add more and it would dissolve again. And you'd add more and more and more and more. And eventually the solvent is absolutely full of the solute. So you've made a solution, so solvent and solute together, which is very concentrated. So every little bit of liquid has an awful lot of solute dissolved in it. A dilute solution, however, is one where only a little bit of solid is dissolved in the solvent. So that's a solution where for every, say, milliliter or centimeter cubed of liquid, there's not an awful lot of solute that is dissolved in it. An example of this would be if we had liquid water in a beaker and we added a small amount of a quite brightly coloured chemical called copper sulfate, we would get a solution which looks a bit like this. So you can see the water has changed colour a little bit because this nicely blue coloured substance has dissolved in it. If we added quite a lot, you would get a much bigger colour change. And eventually you would add so much that there was no way more copper sulfate was going to dissolve in it. So in this, the unsaturated is the word we use. So unsaturated means it can take more. So an unsaturated or dilute solution is one where only a little bit of solute has been added to the solvent and the solution could take more solute and dissolve it. A saturated one would be a solution where a lot of solute has been added to the solvent and the solution is absolutely jam-packed and can't take any more solute. If you add more solute at that point, you start to get big lumps of copper sulfate at the bottom of the solution. And that means that the solute, the copper sulfate, is no longer dissolving. You can do a really, really interesting experiment where you do something called supersaturation. Quite often it's good to heat up the solvent and dissolve as much solute as you can. And as it slowly cools down, the solute comes out, it undissolves from the solvent, and it starts to become a solid again. If you can do it properly, you can build absolutely massive big crystals of the solvent, the solute as it comes out. A more everyday example is diluting juice. So I know when we're adding diluting juice to a liquid, we're not adding a solvent, so it's not really a solute, but it's the same idea. So a little bit of diluting juice in your water, you get quite a dilute solution. A little bit more of what we're treating as the solute, diluting juice, you get a darker, more concentrated solution. More, darker, more darker, more darker, and eventually you've got very concentrated juice. What is actually quite cool about this science is that if you made dilute juice and put it in a special machine called a colorimeter or a spectrophotometer, it would give you a number and it would say, hey, we've tried to shine light through that solution and this is how much light actually managed to get through the other. And if you put the same, this slightly more concentrated in, and put it through this colorimeter, it'd give you another number. If you did it with this, it would give you a different number, this a different number, and this with a different number. And what's quite cool is if you did a line graph then, so how many spoonfuls of solute I dissolved in the liquid, so 0 spoons, 1 spoon, 2 spoons, 3 spoons, 4 spoons, 5 spoons, 6 spoons of solute, and then you plotted the numbers that came out of this cool machine, the colorimeter, on the y-axis, it would give you lots of dots. You could join those dots together, and then I could give you a random diluting juice, and you could say, hey, I only like diluting juice that's had 5 spoons of solute added. And you could check with the colorimeter if that's what I've given you. You could put the juice that I've given you into the colorimeter, and it will give you a reading here, and you would go, wait a minute, Mr. Collier, you've given me one that's got 8 spoons of solute in it because I've used my fancy graph and it's told me that. So these are quite cool, actually. They're called colorimeters. We use them as you go up the school with what's called calibration curves. Another example is tea. So you see on the one line here, this is someone who has made different strengths of tea or coffee. So this one's really strong, concentrated coffee or tea, maybe less solute, less solute, less solute. And what they've then done is they've actually made 4 cups that were this strength, and they've added no milk to everything on the top line. A little bit of milk, a little bit more, lots and lots and lots and lots of milk. And they've said, oh, look at this, you could actually graph this on your spectrophotometer colorimeter curve as well. If I have lots and lots and lots and lots of solute and I add no milk, this is the color I get. If I add less and no milk, less solute, no milk, less solute, no milk, you get this pretty color chart here. So if you add pretty much no coffee and lots of milk, you get something that looks like this. So hopefully we understand how you can make solutions of different concentrations. You can add lots more solute to get a more concentrated solution, or you can add less solute to get a less concentrated solution.